What an unbelievable day. It was crazy. I'm an Olympic athlete, so I've been training for the Olympics for about 4 to 5 months. When all of a sudden, my fellow trainee and best friend, Maria Sharapova, gets dragged off the tennis courts mid-match, accused of blood doping. That's right, blood doping. And not only that, now she's facing 2 years in prison. They really don't take something like that lightly in the United States. Wait. You're probably wondering at this point what blood doping actually is. Well, blood doping is defined as increasing the blood's ability to carry oxygen by increasing the number of red blood cells in the body. Now, this is usually a process done by athletes to improve oxygen flow to all parts of their body, resulting in better stamina and longer bursts of energy. Blood doping can also affect aerobic capacity in a few ways. First, it increases cardiac output, aka the volume pumped per minute through the body. And second, it can also increase the concentration of hemoglobin, the protein in blood responsible for transporting oxygen, as well as maximizing stroke volume, the amount of blood pumped by one contraction of the heart. Increased hemoglobin mass, maximum cardiac output, and maximum oxygen extraction can all lead to increased aerobic capacity and maximum oxygen uptake. Blood doping also increases hematocrit, or packed cell volume, in the blood. The standard hematocrit of blood is 45% for males and 40% for females, but blood doping can increase that by 2 or 3% for both sexes. Now, there are multiple methods by which blood doping can be done. The first way is injecting oneself with the hormone erythropoietin. Erythropoietin is normally secreted by the kidneys to stimulate production of red blood cells, otherwise known as erythrocytes. When injected, erythropoietin stimulates further projection of erythrocytes, even if the hematocrit, remember that word from earlier, is where it's supposed to be. Another method of blood doping is something called autologous transfusion. That's basically when a fixed amount of someone's blood is taken from them, infused with oxygen, and then put back in the body about 1 to 7 days before a sporting event. Notice that the prefix auto here means self. So in that case, can anyone guess what homologous transfusion is? No? Okay. Homologous transfusion is when someone collects and then infuses the blood of a compatible donor into themselves. So in layman's terms, it's basically like getting a blood transfusion, except these people aren't as sick and needing of it as someone in the operating room. Lastly, a fourth method of blood doping is something called hypoxia-inducible factor, or HIF stabilizer. Yeah, I know, big word, but it's actually pretty simple. HIF stabilizer is originally supposed to treat chronic kidney disease. And if you remember from before, kidneys are the producers of erythropoietin to stimulate red blood cell formation. So what HIF stabilizer does when injected into the bloodstream is it stimulates the process and production of new blood vessels, creating new pathways for the blood to travel through and new routes for oxygen to be taken through the body. Now, the term hypoxia refers to the deficiency of oxygen in blood, so it all adds up as to why this method is also one of the many used for blood doping. Well, now that we have all the methods covered, there are probably some questions from the audience. No? Really? Well, I have questions, and since my good friend Maria is in a bit of a bind with the law right now, it looks like I'm going to have to answer them myself. First of all, you're probably wondering, gee, this actually sounds pretty beneficial to athletes. What could possibly go wrong? Well, I'll tell you. Remember what I said before. Blood doping increases blood hematocrit by about 2 to 3%, which might not seem like a whole lot, but realize that 2 to 3% of the blood in your whole body actually adds up to quite a lot. considering erythrocytes are the most abundant type of cells in your bloodstream. And the blood vessels that carry all this blood are only so thick. So when one increases their hematocrit, it's like a competition to get through the blood vessels. Since flow is pretty crowded, it can get pretty chaotic and cause a phenomenon known as drag. Drag is basically when erythrocytes traveling through the blood vessels bump against the endothelium that lines the innermost part of the blood vessel, called tunica interna. Now, usually cells never brush or drag against the tunica interna unless there's a puncture in the blood vessel, which can occur when you injure yourself. When that occurs, the blood, of course, has to form a clot to stop blood loss from the body. So thrombocytes, a fancy word for platelets, rush to the scene in the vessel where the dragging occurs and immediately signal other thrombocytes to come and help form a clot. So you see the problem here with blood doping is that a big clot, or thrombus, forms anyway regardless of whether or not there's a puncture in the vessel. And that makes blood flow obstructed and prone to even more drag. And you could see how that could all go downhill. Furthering on that, an embolus could end up forming. A thrombus can evolve into an embolus, which is a blood clot carried by the bloodstream that can end up lodging in a blood vessel and killing you. Yeah, that's right. Blood doping can actually equal death. Also, since blood thickens from blood doping due to the excessive clotting in erythrocytes, heart attacks, infection of the heart's myocardium, thickest middle layer, and muscle, or strokes also increase in likelihood. In addition, blood infection can occur if the parties participating in blood doping don't have enough time to properly cross-match donated blood with the recipient. You know, since us athletes are constantly pressed for time. But sometimes it's not even a matter of time. Blood is very delicate, and if not properly stored, it can also lead to deadly blood infection. So now that we had the darker, more serious stuff out of the way, let's answer another burning question. But how can someone like my dear friend, Maria Sharapova, be caught for blood doping? Well, granted, the effects of blood doping aren't as physically evident as, say, steroids, but testing for it is actually pretty simple. In 2003, it was discovered that urine could actually be tested for the presence of recombinant erythropoietin that isn't exactly like the rest. Since urine samples are pretty much required anyway before major sports events, blood doping can't exactly slip past undetected quite so easily. The first test was actually presented at the 2000 Olympic Games in Sydney, Australia, using blood and urine screenings. But since urine exhibits a better reading, not to mention saves thousands of dollars by cutting costs of testing in half, urine samples became the official testing method of blood doping in 2003. Also, in 2004, a test came out to further detect the presence of synthetic oxygen carriers, either hemoglobin-based carbons or perfluorocarbons, that are present in doped blood, making blood doping almost impossible to get through tests undetected these days. Now, Maria is unfortunately not my only friend suffering the consequences of blood doping. Other athletes caught for blood doping include cyclist Lance Armstrong, for years too, boxer Shane Mosley in 2003, and American cyclist Floyd Landis in 2010. It's sad what the world of athletics will do to someone, but not everyone plays fairly. But remember, you can't spell blood doping without dope.